Yes, but how you are proactively?
Yes,
but we already have a mechanism in MSF for reactively detecting charges, right? Yes. If you see your ADR drop in the cell,
no, that's reactive.
That's what I'm saying.
That is reactive.
Yeah. Same with the reactive mechanism. No.
Yes, the reactive is very useful because it's really, looks like
You need to duplicate duplicate slot allocation detection. So when you allocate the slot randomly, you send a bucket there, and if anybody sees that, oh, that's mine, not yours, please
but it's a problem. You don't know how the other guy uses it. Meaning that if you measure it, if the other guy uses it, just sends a packet of 10 slots.
But there's somebody listening. There's somebody.
I understand.
There's always somebody listening.
I start the meeting.
I understand the frame. If you said podcast frame,
you're starting the meeting.
No way. It's not allowed. What I mean?
Of course it's allowed. Because I will make it.
Guys, this is not IPv6 over flying objects. So if you're looking for 6TISCH, you're in the right room. Otherwise, maybe it's the right time to leave. We are going to start the meeting. If the guys at the end of the meeting could close the door, that would be really appreciated. So do we have a minutes taker? We do. Oh, thanks, twice. Do we? The links? Well, yeah, I went through all of them, and maybe it's the magic of PowerPoints, but they were fixed.
Why are you using this is the wrong one, IETF4?
Yeah, this one is the wrong one. So just
This one? It says 5?
No, tools.ietf4.
Yeah, had many mistakes, but
Oh,
so we moved to it.
Oh, we moved to okay. So I thought it was the 105. So I looked at the 105, it looked correct. So you said, hey. So I misunderstood your email.
There was two.
Let's try and can hide another. Okay, so this is 6TISCH. We have a short meeting.
Is it on? I think the microphone is off.
How do you turn this thing on?
There's a switch in there.
Switch. Okay. So we have 1 hour. We'll be going mostly through the interesting piece, which is the security, the minimal security last call and all the security discussions that we've had around ASN. So I asked Manisha to actually do something which is a bit unusual, which is spend more time and talk about how things work, as opposed to just say, like we usually do, here is what's changed, if everybody's okay, let's move on, right? So I really want to have a technical discussion on security and close up the security section of minimal. And we have Tero and Marisa in the room, so I'm quite confident that we will achieve that. So this is an IETF meeting. The usual not well applies. If you're aware of any IPR which applies to something which is discussed today, either you refrain from participating or you announce the APR from you, for your sponsor, from whoever you're aware of. If you don't want to do that during the meeting, please come to the chairs at the end of the meeting. It's not the only best practice that applies to this meeting. There are a number of best practices. They are listed here. Some apply to harassment and the way the working groups operate. All of those best practices apply to this meeting. We are being recorded by Mitico. Actually, they will publish the recording on YouTube. And what's even better, if you can click on some sections, on some part of the YouTube thing, and you can get the transcript. It's not perfect, but it's kind of impressive that we are there. So it's being recorded, it's being transcribed. You'll be on video. If you want, if you come to talk, you better sit on this red cross that's behind my feet, so you'll be so nice on video. We'll be passing the blue sheets in like 10 minutes because we're used to the crowd, which comes a bit late. So we better pass the blue sheets with a little bit of delay as well, and captures better the people in the room. Usual links, so they are mostly right unless they are wrong. And so the Etherpad should not have tools. That's okay, so remove tools. And the P should not be there either, or it should be, I don't know. I mean, since it changed, I'm not sure. So the usual intro status, we'll go through the agenda bashing, If you're unhappy with anything in this agenda, please let us know now. So we'll give you a status of what has been around in the working groups that 6TISCH interferes with. We'll give you a status on the architecture. That's going to be me. Then I'll pass the ball to Manisha. And as I said, Manisha will go through the operation of Minimal, and in particular the resolution of the issues that we found discussing the 6TISCH architecture security section. And then Michael is here. Oh, is the new, okay. So Michael will discuss 2 drafts, and I have slides only for 1. So I expect that for the other, you can live without slides.
Sure.
Unless you send them right now, and I can push them, but I don't even have them. And Marco Tiloka asked us to be pushed at the very end of the meeting. So we did this swap in the agenda. Michael's draft and the dynamic scheduling things were swapped. It doesn't mean that Michael can spend all the time in the world and consume MSF time. It's not a matter of priority. So Michael, please stay within your schedule, and then we'll be all right. So since IETF 104, what happens is great progress at 6 low. So, you know, we depend on the backbone router drafts and the address protection thing for the architecture, and those 2 have progressed past last call, and they're in the careful hands of Suresh. The fragment drafts have also been past last call at 6 low. So there is a little bit question about whether the first of those 2 should be informational or standard track, because the second one uses it and it's standard track. So there is a normative downref if the first one is just informational. So it's Suresh to give us guidance there. Ripple and aware leave, which is also a nice thing for us, is adopted at role. OSCORE, on which we depend for Minimal, is RFC. And so the last thing that was really impacting us, which is this lake discussion, is now happening, and there was a buff at this IETF. And that's where HEDOC could sit if it's adopted. We have still a number of things which are happening that relates to us in different working groups. At this point of time, the most interesting is probably the ANIMA constraint voucher. So I expect that when you talk about zero touch, Michael will give us a status on the constraint voucher as well. And here is the kind of a snapshot of the recent activity on the Milestones. So that's where Suresh, you've heard about us recently. So a good number of our milestones are now green. And we added 2 milestones for the MSF and for the enhanced beacon, because we adopted enhanced beacon, and Michael will talk to us about it. It's a very simple draft, very useful. So we expect to progress this very rapidly now. And then we'll discuss what happens to zero touch, but pretty much everything will be complete. So between now and Singapore, we'll be in a situation where the working group has completed its job. So we'll be facing 2 possibilities. We close the working group, which is perfectly fine. We're done, we're happy, we call it victory. Or we look at the one thing that we started with and we never completed, which is scheduling time slots for the GMPLS operation that we've been discussing at the very beginning. Initially, I thought this could go to the raw effort, but the raw effort will end up being a routing area effort, dealing with layered, what happens above TSCH, but not within TSCH, meaning that it's a really orthogonal work. So raw will not be the place for scheduling time slots for TSCH, meaning that we need to find a home for it, and that could be a reason to reach out to 6TISCH. That's where I am. So that's the best I have at this moment. So here is what has changed. If you have any question on this, we've deleted terminology because it was merged into architecture, and they are both in ISG review. We passed most of the review. I guess we're all green. Some people did not maybe confirm to you, Suresh, but my best knowledge is I have no pending action. And we need to switch slide. Can you go to, so you remove this, and you go back. And you click this cross here on 6TISCH. Then you go to down. Architecture. Now you need to press this, and we have. There we go. Now you know. Okay, so the architecture, like I said, passed most of the reviews for the ASG. So I expect that will be in Auth 48 very soon now. Well, we are in the RFC editor queue already, Suresh? Maybe not? No, we're not. But I expect to be there soon. So the queue, there are people in the queue, so it will take the time it takes. But as far as I know, the current version of the architecture is very, very close in terms of content to the RFC. We switch some subsection from high-level architecture to components back and forth, because it really depended on the reading of the different reviewers. So I tried to be consistent and make sure that I did not undo for one what I did for two, right? So we had like 4, and addressed, Francis, Gory. So thank you all. Another big change was the security section. You've seen all the discussions on the mailing list about the security section and the review there. So we're happy with the text right now. The Gory details go actually in the minimal draft. And so that's what Malisha and Tero will be discussing today. And then there are many small editorials, so I won't list them. Just look at the diff if you're interested. And that's pretty much it. And Manisha, if you want to come in for the next. Any question on the architecture? No, I will do it. You can start.
Okay, good afternoon. My name is Malisha Ujanit. So I'll be on behalf of the authors of draft IETF 6-TISCH minimal security. I will be presenting the updates to the draft since the Prague meeting, as well as the latest discussions that were recently held on the mailing lists. So since Prague, we had 2 versions published. We had version 10 and version 11 after Pascal's review. Thank you, Pascal, for the review. We shipped the document to Suresh, but in the meantime, we had an overlapping discussion during the ISG review of the architecture that influenced some of the text that we need to update in minimal security draft. So I will be summarizing that and giving a proposed resolution. And essentially, this is the goal of the presentation today: summary of changes in 10 and 11, and the discussion of the ASN replay attack that is on the mailing list. So the update in 10 that was discussed in Prague, we found a resolution that includes the expansion of section 8.3.3, which concerns essentially the scenario of the joint registrar and coordinator failing, partially failing, essentially failing to preserve mutable context parameters in OSCORE, but able to preserve the pre-shared keys from some database, for instance, and the pledge identifiers. So we had to recover from that, and the recovery process works as follows. First, in case the failure occurs, we rely on out-of-band knowledge, out-of-band coordination between the JRC and the 6LBR of the network, such that the network is reinitialized. Then once the network is reinitialized, this will essentially force all the nodes in the network to rejoin. To send the join request as per draft as per minimal security normal join process. But on the JRC side, we know that the failure happened, so we can restart. We can reject the first join request in order to prevent the nonce reuse on the OSCORE level in the corresponding join response, and instead we trigger this procedure that is defined in OSCORE in RFC 8613 that involves the derivation of a new context context identifier. So the procedure works as follows. essentially in the first join request, this is as normal. The KIT context parameter carries the EUI64 of the pledge, but the response, instead of the regular join response, now is a 401 unauthorized error containing as KIT context a random nonce, and this context here, this message here is protected with the concatenation of EUI64 and the random nonce, and which triggers essentially the pledge to derive a new to select a new random number R3, to concatenate it with R2, and to protect the following join request that it makes to the network. And finally, as the output of this procedure, from KIT context that is EUI64 of the pledge, we end up with a new KIT context and fresh parameters that allow us to prevent the nonce reuse in the join response. So this procedure is entirely defined in 8613. So we merely reference it in minimal security, discussing extensively the attack and what happens, why this procedure is needed. So right now the procedure is recommended, with the other option being that the provider needs to go into the field and reprovision the devices. So the second update in 10 relates to the error handling on the level of constrained join protocol. So in the previous version, this update came after Christian's mail discussion on the mailing list, and the issue in the previous version was that the error signaling was not done in a RESTful way, such that the request was referencing a previous request, and it would prevent essentially the server from handling the join request in a stateful manner. So essentially what we did is that we redefined the CBOR structures that carry the parameters, and they now contain all the information for the error handling to occur in a stateless manner. So essentially, it works as before. If the join request fail, if the processing of the join response fails, the subsequent join request will contain the CBOR unsupported configuration parameter that will include essentially what went wrong in a stateless manner. And now we have this structure that is an array that carries unsupported configuration, that carries unsupported parameter sequence of CBOR elements, with code being unsupported on OLMAR formed, and the intent here being to signal from the pledge to the JRC that it cannot essentially configure some part of the configuration that it received in the response.
Randy Turner from Williams & Gear. I was questioning the previous slide. So one pledge can fail a join, and the whole network has to rejoin. Is that the implication?
No,
I missed something. What was it?
So it's the join registrar coordinator that fails completely. So it's the failure event.
Okay.
It's the failure event. So it's here. It's the failure event of the join registrar coordinator, where the join registrar coordinator loses all the RAM state, for example, but it is able to retrieve pre-shared keys of all the pledges that it manages in different networks out there. So it's the...
Okay. And the implication of the attack is described in the update?
The implication of the attack is that the join response here would have a two-time pad on the nonce essentially used for the join response would be used twice, such that there would be a two-time pad on the join response. So cryptographically, the security properties of the join response would no longer hold.
I was just trying to clarify this because that's to force one of our networks to rejoin is a huge
Yes.
a huge deal. So I was just going to make sure the bar was set high enough.
So this is, yes.
So Michael Richardson here. So this is a catastrophic kind of event where, you know, the plant is still alive, but the fire in the office destroyed all the equipment, okay, that operates the plant. And afterwards, you buy new servers and you restore from backup, but the backups don't have aren't, you know, we're a month old. And so you don't have all the latest information. At this point, you know, you have no front office, back office. You're going around, you're going to be pushing buttons on every single thing as you initialize the whole factory, okay? So yes, you're absolutely right, but the point is that it would be terrible if you also have to unmount all the devices and put new PSKs in them, okay? So that's even worse. At least all you have to do is somehow power cycle them and get them to keep going.
But you don't even need to power cycle them.
I'm saying you need to have some kind of a network reset to do.
Yes, you need to restart.
Wait, they go out of sync, their batteries run low.
Please speak on the mic,
Yeah.
Terrell. Please go to the mic if you want to speak, because people are listening.
So Tero said that they get out of sync anyway, because while the firefighters were there, while the firefighters were there putting out the fire, the network fell apart because they got out of sync. And so they all go back into join state again. And so you don't even have to do what I just said, I think is what Tero saying. You don't have to push a button everywhere. They all just go, oh my God, the network went away. I have to reinitialize. And as soon as you get that JRC server back running, okay, you're good. You've restored the 6-week or 6-month-old backup or something like that. And life continues. And this is what makes sure that it continues.
Clarifying question, during all this time, the network could live the way it was, right? You don't have to brutally stop it.
If the network kept going because it still had power, then it would just keep going, right? We wouldn't have to rejoin. If it was only the JRC that died, okay, and the rest of the plant was fine and it was powered and kept running, it would just keep running.
You just cannot add new devices.
Can't add new devices, can't do anything else. Something else comes along.
Clarification, you're not entirely correct on that, because the problem is the parameter update response that comes from the JRC. So if JRC loses the state,
yes.
If the JRC loses the state, it needs to, right now the text in the draft says, okay, you have to force out of band all the 6 LBRs to reboot. Why? Because on the parameter update request, for example, for rekeying or something.
Yeah, of course. As soon as we get to a rekey, we're screwed, and we have to rebuild the network because we've lost all that state. I totally agree with you. Yes, you're absolutely right. What I'm trying to say is that during the period that the JRC was being rebuilt, being reloaded, okay, unless the network had to do something involving the JRC, it could keep operating.
That's correct,
but it can't go forever, right? So at some point you would say, okay, Sunday morning, well, you know what, I hope we can.
There is no red button with emergency stop in that scenario.
Pardon me?
There is no red button with emergency stop on that scenario.
There isn't, you don't have to do that,
Of course, one of the things will probably also happens that because the master time coordinating neighbor goes away, because I mean the JRC is usually probably the first, connected very tight to the coordinator, and when that time connection goes away, at some point you probably use enough time coordinating neighbors, and then you don't trust anybody because then you don't have any neighbors anymore, and then you drop out of the network, and the first node drops out of the network, then all of his children drop out of the network, and then you lose out of network.
Yeah, this is the case if JRC is co-located with the 6 LBR, but we also support the case where JRC is in the cloud, for example, and manages multiple networks. Okay. Yes, so then we also had the update 11 after Pascal's review. So it was mainly an editorial update with update of references and a couple of shoulds in section 612 regarding the setting of the diffserv code points, and a couple of nits fixed here and there. So now I would like to skip to the latest discussion on the mailing list. So we have essentially two issues open. But before I go into those details, I will give some background on IEEE 15.4 that influences these discussions. So first one is the construction of the layer 2 nonce in 802.15.4 TSCH. And as you can see, the nonce is a 13-byte octet stream. 13-octet byte stream that contains the source address of the peer sending the frame and the ASN. The ASN is the absolute slot number. It's the local notion of time at the device. And this is implicitly put into the CCM procedure as the nonce in order to perform the security procedures of the CCM security procedures. And then the source address can be either be the EUI64 of the sending peer, or its short address, in which case it is derived as follows. Essentially, the first three octets are the company identifier, reserved 00, PAN ID, and the short address, which is of interest for us. 2-byte locally unique 2-byte address that is assigned by the JRC to the pledge at the join time. So now this slide is important in order to understand when can the nonce reuse occur. Usually the EUI64 is globally unique. So when the node is using that in the layer 2 security procedures, there is no risk of this part of the nonce being reused. But then, as we can see later, then in the attack that Tero brought up, the notion of ASN is critical, as if the ASN, as the older ASN is used, essentially the nonce reuse can occur. So to understand better how the ASN is distributed, I gave here this slide with essentially the pledge in scanning mode, listening for beacons from the network, and two advertising nodes that send beacons at a different instance. So the pledge, according to RFC 8180, pledge waits for max CB delay time to find num numbers to wait neighbors, essentially two parameters that specify how long should be the maximal scanning time be, and how many neighbors should at least the pledge listen for. And upon the expiration of this time, essentially the pledge selects one of these advertising nodes as its joint proxy, with the beacon containing the ASN number, with a beacon containing the information element carrying the current ASN in the network. And now beacon is protected cryptographically, it's authenticated, but at this time here, the pledge does not have a means of verifying it. And it does a leap of faith and sends the join request and join response through this join proxy. But without layer 2 security involved, meaning that ASN that it heard from the beacon is only used for communication purposes, but not for crypto purposes. So now to explain how the attack works, we assume the attacker is place a man in the middle between the joint proxy and the pledge. And it listens for some time and stores the enhanced beacons the legitimate enhanced beacons that were exchanged in the network, and replays them at a later time to the pledge. Now, pledge, without being able to validate here the content in the enhanced beacon, it takes this notion of ASN and sends the join request at the corresponding slots, and the attacker forwards this onwards through the legitimate network to the JRC. The JRC sees this as a fresh join request, so it's a legitimate pledge that has the keys involved, so everything is fine. It will respond with a join response with the join response currently not having any layer 2 protection on this leg between the join proxy and the pledge. So all of until this point, everything is fine. And even here, when join response is received, we have text in the draft that now states that this enhanced beacon that was used to select the join proxy should be stored in memory and then validated once we have the corresponding key. So this attack still works as if, because the enhanced beacon will validate, as it's a regular enhanced beacon from the network, but it will be a replay, so the ASN will essentially be lower than the one that is currently going on in the legitimate part of the network over on this side. So the problem arises now after the join, the join process. Once the join response is received and the replayed enhanced beacon validates, the pledge's notion of time will be this number here, 23. 23 plus the time that elapsed to get to this point here. So let's say that's 55. So when the pledge now uses the keys that it obtained from the join response, it will use the ASN 55 in this derivation here that might have been replayed before from a previous attempt of joining the network, from a previous network exchange essentially, and which might lead to the this frame, to the nonce reuse at layer 2 of this particular frame with ASN 55. So essentially the nonce reuse happens in two cases, if I'm summarizing the mailing list discussions correctly. If the short address given to the pledge was reassigned, so now the pledge was given a short address that was used with ASN 55 before, and if the pledge is joining for the end time and essentially previously it sent frames secured under ASN 55. So here the proposed resolution is quite simple, but it involves some cross-layer signaling, some cross-layer operations essentially. What we propose, we had a side meeting involving me, Tero, and we also discussed with Pascal on the proposed resolution, how we should approach this problem. And essentially it involves authenticating at layer 2 the join response on the leg between join proxy and the pledge, where previously there was no security involved. So this is a bit tricky because join response, join proxy already is part of the network, and it has the keys that are used in the network. So it can send this frame authenticated but not encrypted for the pledge. So essentially, when pledge does, the process is as follows. The pledge sends a join request as before without any layer 2 security. The join request goes to the JRC. JRC responds with the join response. So all of this logical connection here goes over the network encrypted at layer 2, so this is all fine, but the change comes here. So essentially when the join response comes to the join proxy, instead of sending it without any layer 2 security, join proxy sends this with one of the first 3 security levels in 802.15.4, which involve only authentication of the frame. So now this means that the pledge receives a frame that has the security level bit set, but that it doesn't have the key to verify the validity of this frame because the key is inside this frame. So the procedure is as follows. We all, essentially the pledge discards the layer 2 verification. It decrypts and verifies the end-to-end security session of OSCORE. From this co-op message and the coding of the CBOR object, it gets the layer 2 keys and now passes back the whole thing into the layer 2 machinery in order to validate the frame, to validate specifically the authenticity at layer 2 of the frame that it used to obtain the join response. So essentially, the change is only that. The change on a high level is that this frame here, instead of having no layer 2 security, now is secured using first 3 security levels of IEEE 15.4 involving authentication but not encryption. So there are a couple of caveats with this approach. First off, it is a bit tricky in terms of the implementation-wise to process this, to process the frame that has the security level bit set, but the security processing fails, especially because this frame is unicast. So there is a special mode in 802.15.4 called promiscuous mode that allows essentially when this attribute is set in 802.15.4, all the frames, regardless of the state of the security processing, are passed to the upper layer. Tero?
So actually, promiscuous mode passes everything up to the higher level. So it's not, regardless what is, everything that passes the the FCS is passed up. So if the checksum matches, it's passed to the upper, regardless if it's destined to you or not. There is another way, which is currently not possible, but it will be in future, hopefully next year, is that when we receive a frame that is, we don't have a keys, IEEE 15.4 says that we call this MLME, there's this one MLME called that is COM indication that tells you that there is something happening from the network, and we have received the frame that we don't have a key. Currently, that MLME call doesn't receive the frame. There is no frame, there is nothing there. It just says that, oh, we received the frame from this person and we don't have the key for it. Install the keys, please. What we are planning to do in the revision, we are doing 15.4 revision now. We are planning to add the information there, so the higher layer actually gets the whole frame, so you can actually process it there in the future. Hopefully, this will be in a 2020 version of the 15.4.
Okay, so to summarize, currently we have a way forward with the promiscuous mode, and in the 2020 revision there will be essentially a cleaner way of doing the same thing. So. Pascal?
Yeah. Just, if really you wanted to avoid this weird back and forth between the lower layer, and you could, since the joint response is reinitiated by the joint proxy could always place some field in there where he signs the nonce at the upper layer, if you like, just as opposed to just relying on the lower layer, doing the exact same thing, but inside the packet as opposed to outside.
But so we don't have a security association between the joint proxy and the pledge. So this is the problem. So the only security association of the joint proxy and the pledge are the layer 2 keys. And this is exactly what we are doing at layer 2.
Yes, exactly. So, but what I'm saying is you could take the layer 2 keys, sign something inside the packet as opposed to, but it works the way you did it. But if you just wanted to avoid the back and forth, you could have used layer 2 key to sign something, a small option in the packet and be done. If you really wanted to. Same thing, right?
So you are saying we could add something on the end-to-end layer? Microphone, yeah.
I'm saying the joint proxy could have added an option inside the message that it would have formed itself with a MAC, which would be the equivalent of the MAC that you get at the layer 2 using the layer 2 keys. But that would not, so you could have done it at the quote-unquote upper layer using the layer 2 keys.
So this would be possible, but for cryptographic hygiene, we would need to derive, we would have to use different keys than the one that is used at the at layer 2.
And it also is problem that we want to tie this authentication to layer to ASN.
Yes.
And the problem with ASN is that when your joining proxy or joining nodes is sending the frame, they have no idea what the ASN is going to be. Yeah. Because they create the frame, they send it out. The MAC layer takes that frame, waits for the suitable channel, suitable time slot to be. And it's busy. I go to the next one. Oh, that's empty. Okay, now I send it out. And then the ASN is going to be what is going to be used. For upper layer, there's no way of it knowing the ASN.
Yeah. Yeah, so even though it's a single hop away, it's the upper layer. So I concur with that. Yeah. 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 So this is one. So the use of promiscuous mode and the update planned for 2020 revision of 15.4 will make this essentially possible in terms of security processing. Another caveat is related to the layer 2 ACK of the join response. And the join response, since the join response frame, as you can see here, it is now sent with the security level 1 to 3, so authentication but no encryption at the join proxy. So at the pledge side, it does the special processing that I just presented here. But the problem is that since this is a unicast frame, the pledge needs to send an acknowledgement, a layer 2 acknowledgement that normally in TSCH is protected as well, using the same level of security that was used for the incoming frame. And the problem here is that there is no enough time to do the whole upper layer processing and before sending that layer to an acknowledgement. So the enhanced acknowledgement that is sent back here can only be sent in without any layer 2 security. And this still works with the current configuration in the draft because the join proxy has the sec exempt attribute set for this pledge. That allows essentially the frames that are unsecured to be passed to the upper layer. So,
clarifying question. So, say this wouldn't work, right? What would happen? Probably the join proxy would retry the join response, and then it would work, right?
So, essentially, if this wouldn't work, join proxy would retransmit.
And then at some point, the crypto would be done at the upper layer.
Yes.
And it would work.
Yes, exactly. So, yeah, that's a good point.
So actually, yes, that's actually a perfect point, because even if you don't be able to do this kind of crypto message we are saying to, we can actually just say that the responder, the bridge just takes the frame, ignores that it failed the security, takes the OS core there, and puts the keys in and waits for the retransmission. And when he hits a retransmission, then he knows that, okay, he can verify that the retransmission content is same than previous, that he needs to check out that it's same, because otherwise he doesn't know it's an OS core. Actually he does that anyway because he doesn't know it's retransmission. He just sees the OS core name and then he acts it.
Actually, I like the properties of that because now he's sure that everything is set. Otherwise he's guessing.
Okay, so and the last couple of slides. So there was one additional thread that Terra started on the mailing list regarding the CCM security proofs, and it turns out that the CCM star security proofs do not apply to the TSCH mode of 802.15.4. So what I'm discussing here is a generic 802.15.4 situation, not specific to 6TISCH, but since we are using the TSCH mode, obviously it relates to us, so we can put some text in the minimal security draft. So to come back, so essentially CCM star security proofs do not apply to the TSCH because they assume that they require that the nonce contains the security level, which is the case with regular 15.4 but not 15.4 TSCH. So with this, we revert back essentially to the we can still rely on the proofs of CCM, but the limitation there is that a single key can only be used with fixed length authentication tags, meaning that we need to prohibit the mixing of different security levels in the network where different pairs of nodes use different length of the authentication tag or message integrity code MIC as with the same key, obviously with the same key. So what we propose to be added in the draft is just a small paragraph in this section on IEEE 15.4 keys, forbidding the use of different security levels with the same key. So that's pretty much it. I don't know if I think I'm good on time. So the conclusion is, so these were the latest discussions that were triggered essentially after the review of the architecture draft that that inspired this discussion. So it's good. The document is shipped already to the AD. So I think I'm not sure now whether we should wait for the reviews or do these changes immediately.
Yeah, make the change immediately because I haven't read it yet. So just do it now, and so I can just read the latest draft. So it's on my AD review pile. It's 4th on the pile. So I'll just like get to it probably next week or like just a week after that.
Okay, that's perfect.
So just do it like whenever you can.
So we have the resolutions. It seems there are no objections to the resolution. So I think it's just the matter of editorial text, adding the text to the draft. Okay. Yeah, so that would be all. Thanks.
Thank you, Manisha. And actually, we're 5 minutes in advance, so we're pretty good so far. And the next, I guess, is Michael, if my memory serves. So. Yes, it is you, but we only have your slides for non-speaking. The first topic was zero touch. So if you want to give us news on the voucher and stuff.
I don't think I sent slides because I didn't think there was news. So zero touch. Yes, I have posted a new revision of the document. It is significantly shorter. It had expired, I believe, sometime last summer. And it is significantly shorter because the goal is always to have the work done elsewhere, and that work is getting done. Specifically, you may be aware that the base Zero Touch Brewski document is at the IESG, and a lot of discusses. Hopefully, they'll get cleared in the next week, and that will go forward. The DT Security Zero Touch join document depends upon ANIMA's constrained voucher and constrained Brewski document, which is a remodeling of Brewski to ad hoc plus COSI signed CBOR vouchers, and what's the other part? COAP. Yes, OS Core and COAP, okay? And so that's what this document says, and so I essentially reduced it there. I've actually removed DTLS from this document. If you don't like that, we could discuss that point. I've removed many pieces that have since moved into minimal security. So that's why it got much smaller, and that was always the goal. The document was always supposed to say, do A, B, C, D, they're over here, and not document themselves. So that's what that's where that went. But there's no substantive changes to the protocol or the concepts, just the text is no longer redundant. That makes sense to you, Pascal?
Does. Now, I'm just wondering what the future is for this document, because
the future is that the priority for me is to get the documents that this one depends upon through. We had a BOF on Monday called Lake, and if that goes forward, which I believe it will, then we will have ad hoc, which allows us to do zero touch without DTLS. Otherwise, how do we fit monster DTLS packets over, and it doesn't interoperate very nicely with minimal security or OS Core. And if that's the only option, then the answer is we probably don't have anything to advance. But if we have ad hoc or something equivalent in the Lake working group or BOF, then that's good. So essentially that's waiting for that piece, and it's been waiting for that piece for what, 3 years now, right? So that's where that is.
Yeah, because as we said early in the group, right, the group has two options: is to recharter just for the scheduling, or to just disband and call victory. If we do the latter, then this will probably be the only outstanding draft that the work group would have when we quote-unquote shut down. So we would have to see how we keep some lights on so you can finish the work.
That's a good point. Thank you. Actually, and some of us, I think you included, are going to have a chat with Ignis, who is an AD for Anima, as to how do we regroup some of these documents together into the right place, and maybe Suresh, you'd like to join us. We're going to meet right here, right after this meeting, if you have 10 minutes afterwards, that point.
So we'll probably be happy if this is transferred somewhere.
So that would please me just fine. The contents of this document are not particularly 6TISCH specific anymore, and it's essentially all of the things that are, except for the constraints of the solution. All of the things that were 6TISCH specific in this document some time ago have moved to the minimal security document, and that's exactly what the goal was to get it out of something and do that. So.
Any question on this in the room?
I didn't do any slides. I'm sorry. I just didn't think there was anything to tell you. I guess there is.
So that's going to be announced.
Push the button.
Suresh, that's
you have to push the other button, the big button. Yeah, yes. There we go.
Suresh, this is the charter item, well, the deliverable I added to.
Enhanced beacon. Okay. So what's the problem? What is proposed? What we're doing? A problem from some time ago is you have a new device and they would like to do a couple things. First of all, they would like to find the network. They get beacons to do that. They would like to know if they have found the correct network, or rather, if they have found the diversity of networks that they wish to find, and they get beacons from different places and they don't really know where they belong. In the COGIP join process that 6TISCH minimal describes, and DT security depends upon as well, you are supposed to go through all the join proxies for a given network and try them all out. So it's important to know which proxies belong to the green networks and which ones belong to the blue network, so that you can either try the green network and a blue network, and then a green network and then a blue network, and one of them might like you and one of them might not. If you waste all your time on the network that isn't going to accept you, then that's a bad thing. So there's a couple of different things. The second thing that people asked is, well, I would like to have some information about the networks that are there so that I can join the network which either is less loaded or the parts of the network which are less loaded. So you may have several choices in the blue network, as you see, as to different places you could join, and that would determine what's going on. So the question is, can you get this information before you have done all the stuff? In particularly, this not just applies to the join step, the enrollment step, but it also applies to sleepy nodes that may have slept too long and have gotten out of sync on their ASNs, and therefore need to have the keys, but they need to then figure out which part of the network they need to join and do the right thing. So, 6TISCH part. We've created an information element which goes in the enhanced beacon that uses the IETF allocation that Tero Kevanen got us from the IEEE in RFC 8137, and gives us a bunch of things in there. A network ID to tell you which network is which. If you like, you get the lower 64 bits of the join proxy so that you don't have to do a neighbor discovery, a multicast neighbor discovery to find it, assuming that the lower bits are not the same as the L2 address of the beacon that you heard. And then you get some other numbers, rank priority, proxy priority, and these are containers for things. So the rank priority, if I remember right, comes from RIPL, and there's a document in RIPL that tells you how you might like to fill that in. Not this working group's bother, just it's a container to put something in. The R flag tells you whether or not the router would accept, in fact a router, and would accept unicast router solicitations, which you might like to do because that again saves another broadcast. So that's really it. There hasn't been a lot of movement. We've changed the format of this, added and removed some things over the last year and a half or 2 years since it's been alive. And that's really it. We think it's ready for working group last call. There's not a lot else to do. Oh, and we need this because otherwise you can't find the join proxy.
And that was some time ago, but I think I did the Shepard review already on this.
You did do that, and I think I took all of your comments and they're in. Right.
We're completely all set. So I've placed an aggressive date for submitting to ASG because one, it's a simple thing, and second, we're done and very, 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 very stable. So I expect that, I think we did the work group last call. No, I'm surprised. Well,
No, you haven't done a working group last call.
okay.
No,
so-
no.
so-
I keep asking, do you want to do a working group last call? And you keep saying yes, but we haven't done it.
No, wait, no. I sent you review comments. I wanted you to publish my review comments first, right?
Okay, so maybe I have some comments to process. I will double check about that, but they will certainly get
Maybe you didn't
processed.
check whether you did it all, but that was the step.
We'll both check and see if we checked on the checking,
and
and
check
then
that you checked.
but the point is that none of his comments were substantive about changing bits on the wire or anything like that.
No.
They were
So be
fix
ready
a
to
sentence
see
here
the
or
work
there or
group last
something like
call,
that.
like soon. Any question in the room? Next.
As a non-coffee drinker, I've had too much coffee.
Oh, talk me about it. And with this, we'll invite Yach for MSF. So thank you very much. So basically, we had the choice of inviting one of the main authors, but from Paris over the Mythico. But Yach was with us. He knows the spec very, very, very well. And so we asked him to do the presentation on behalf of the remote editors. So thank you, Yach, for actually accepting to give us the status. The slides were done by Tengfei, I guess.
Yeah. Hi, Yasuki Tanaka. I'm presenting the MSF update. So there are 3 revisions, the versions of the MSF draft since last IETF meetings. And the main changes are these 3. But the major things, the first 2, the usage of the autonomous cells and downward traffic things. The first 3, I'm explaining about the autonomous cells. So in the previous, that's the version 3, we had auto up cells and down cells. And auto up cell is basically used for the upward traffic towards the parent, and auto down cells is mostly used for downward traffic to your children. So that specs has been changed, actually they're removed, and we have now the 2 new autonomous the cell types. One is auto TX cells and the other is auto ORC cells. So basically the node, the scheduled auto ORC cell, its slot offset and the channel offset are calculated based on its EUI, the MAC address. And when you have the frame to your neighbor and you don't have any dedicated cell to the neighbor, you schedule the auto TX cell on demand to send out the frame. So the slot offset and the channel offset for the auto TX cell is again the calculate based on that neighbor's MAC address. Once for example, you don't have any frame to transmit to the neighbor in your TX queue, you can remove the auto TX cell. So auto TX cell is expected to be removed automatically. So that's why we call it on-demand schedule. So these figures show the difference between the auto down cell, up cell, and auto TX cell and auto ORC cell, the ideas. So when you look at the node B, in the version 3, the auto B has 2 autonomous cells. One is auto up cell and down cell. Now node B has 1 ORC cell, auto ORC cell, and it has 3 auto TX cell. That is for its neighbors. Another major change is dedicated ORC cell to a parent. So before, the MSF defined the node just after joining the network. The node scheduled a dedicated TX cell to the parent. That is the end of the state of the joining process. But now the node schedule dedicated ORC cell as well with the parent for incoming traffic. So this is the major thing. It's a relatively new idea. So I think the authors expect the more feedbacks on this feature because it's new. Another thing is just the comments which are already resolved. So, and also you can find the details in the mailing list archives. So there are two things remain to be discussed. One is the cell list, about cell list. This is Pascal, the suggestions to how to select the cell to propose in the add request. So the Pascal suggests it's better to avoid the busy cell to put to the cell list. To do that, so do the similar. Oh, you're here. So yeah, please.
Okay. So that would just So Pascal here. Yes, so it really depends on the kind of network you want to build. Some of those networks have many DAGs which are not synchronized with one another, in which case the normal CCA that is mandated by the MAC will work. If there is somebody that transmits, since it starts asynchronously, it will be detected. Now, if you build a very large mesh, and we do build very large meshes, like thousands of nodes, and they are all synchronized, then there is a good chance that there is somebody in your interference domain that may be doing MSF as you're doing it, and that will pick a cell just randomly as you do, and that you would pick the same. And I argue that in that case, it's better before you allocate that cell that you listen a little bit in advance to that cell in the previous iteration, using the normal CCA process, but you just do the CCA window, you don't transmit anything, and you just assert that this frame seems not used, which we can call a proactive validation of the cell. What we have today is a reactive validation of the cell, meaning that if we observe that one cell is not as efficient as the others, meaning there is more collision on that cell than in others, then it's probably getting some collisions. Now, it really depends on the kind of traffic. You may give away a cell, you use it a little bit more, a little bit less. So I argue that the efficiency of the reactive discovery is very difficult to tune properly. And it could take time before you actually discover it's not okay. And so I think that listening a little bit to the cells before you actually allocate them, maybe it's a knob, you turn it on or off, but I argue that it's a useful thing to do. It's being polite, right? Like listen before talk, but it's the TSCH way of doing listen before talk.
I was just trying to think about how to actually do that if you think about the 15.4, MLME things, because I don't think there's a way to do that. You can add a link, yeah, you can say that I'm going to listen in this, but then you only listen to frames that are destined to you. And I don't remember if there's anything that allows you to this kind of promiscuous listening on one specific link on the channel. I don't know if there. Other option, of course, is to do, to send one broadcast frame to that link, because one of the things is that if there's anybody using that link, there's somebody listening that link, and he's listening it all the time. And if you send any kind of broadcast frame on that link, he will ACK it. He will send an acknowledgement back to you. If you receive an ACK, you know that there's somebody using that frame, because somebody was listening it and he ACKed your frame. And he ACKed it because it was broadcast frame. It might be empty frame. It gets completely empty because you don't need to have any content. He will just add layer 2 acknowledgement.
But you will disrupt the traffic. I'm sorry.
Yeah, if they would have been sending at the same time, yes, you could do that.
So take it as a requirement from us that if we agree that we would like to do CCA on cells before you use them, it means that probably we're asking you to do something new at the MLME to give us the access to the passive listening of a cell before we use it.
The problem really is that I need to know what do you want, because it's the TSCH things in MLME are quite vague. They are, very high level, very this kind of wavy. They don't really describe that much of the processing. So that's why it's a little bit hard to say if you can actually do this or not.
The CCA procedure is there. So I'm asking is, can you do the CCA procedure?
Doesn't tell you anything because the CCA is done before the frame is set.
Exactly, but you do it on a cell that you won't want to use, and then you don't transmit anything.
Yeah, but as I said, the CCA doesn't tell you that if there's anybody using that same frame, if he's synchronized with you.
Well, it will detect that there is energy in the air, right?
No.
What does it do?
Because CCA is done before CCA is done before the frame is sent.
Yes.
Even if he's using the frame, a lot.
So I don't want to send a frame. I want to do CCA. What do I do?
Yeah. So you would need to do CCA out of sync of the normal schedule. Because normally what you do, you have a slot starting, you wait for a certain amount of time, then you do CCA, then you finish the CCA, and then you wait a little bit more, and then you start transmission.
Right. So say
and the problem there is that the CCA is done in a sense, or in the location where nobody in the network who is synchronized with you is ever going to be sending anything. And which means that if you want to do the CCA, you would need to be doing that CCA in offset that you normally don't do it, which is a little bit more difficult. Yeah. I was thinking about more or less it would be something that you could actually make a link and say that I want to make this link as a promiscuous link, meaning I want to receive whatever somebody is sending on that link, even if it's not destined to me, I just want to know that if there's something on that. And that would probably be one way to doing that. So we've add one more bit there saying that we have an RX and we have TX and we have shared. We would something have it say, oh, this is promiscuous. I want to get anything on that link that happens to be on the air at that link, and we always listen that. That would probably be solving their problem if I think about.
So let's take that to the mailing list, but I see a need for something like that. I don't know how to do it. I trust you can help us.
I think we had Teng Fei in the queue.
Teng Fei? I don't see.
Hello. Can you hear me?
Yes, we can.
Yeah, I'll raise the hand, but actually what I want to say is kind of what Tara wants to say is about the CCA actually didn't detect the frames. If we really want to like listening to talk, we have to make the cell be a RX cell first, and then on the TX cell. Like it's a reserved at TX cell, but we kind of listening at the RX cell first for a while, and we didn't detect anything, and then we use this TX cell. It just sounds a little. I don't know whether this is standard compliance or any. It just sounds a little strange for me. Yeah, that's what I'm saying.
Well, I hope that, Dominique, you could capture that, because I did not understand everything.
I mean the CCA, because CCA is performed before the TX offset, right?
Yes, I mean, Tero explained that. We understood, I guess, at that point.
Yeah, what I'm saying is that if we want to do something like listening before talk, we have to like treat this TXL as a RXL first and listen for a while to check whether there's a frame in the air. And then if there's after a while there's no frame in the air, and then use the cell as TX later.
Yes, I mean, let's continue that on the mailing list to make sure everybody understands everybody, because we are running out of time for this slot.
Okay. Yeah, no problem.
Oh, yes, Teng Fei, ideally you would go to the Etherpad, right? You're online with it? Can you just type Etherpad?
Yeah, okay. I'm trying. I was using my phone. Yeah, I will do that.
Perfect. Thanks so much.
Okay, and also, so Teng Fei and Marisha and Thomas had the offline discussion about the negotiated RXL, the dedicated RXL to with your parent. So again, the negotiated RXL, that idea itself is new. So, and the many comments are expected on the mailing list. So yeah, and also there's no information about the MSF is implemented on the OpenWMSL, of course, and the 6 simulator, And now we have the MSI implementation for the Contiki energy. So Tengfei and I are planning to have the local interop the test based on the latest draft to make sure the spec is ready. Thank you.
Nice. At some point in one of the slides, there were like 2 items that still needed discussion. We really would like to get this to workgroup last call. So how can we move on with those 2 discussion items? I don't remember which one they were, but it was to be discussed: rules for the cell list and downward traffic adaptation. Guys, if you could raise those questions to the mailing list and explain exactly what they are and make sure we discuss them. So, because the goal is to workgroup last call this year, right? So somewhere in fall. To get there, we need to get those 2 issues resolved, and so please bring them to the mailing list. And then we'll do workgroup last call. Okay? Tengfei?
Totally agree.
Nice. Okay, so with this, we'll move on to the next, and that's Marco. Did Marco? Yes, Marco is here. So thank you for rushing to us, Marco. It's very nice.
Thank you for the bashing.
So this is the robot scheduling. It's part of also the scheduling discussion. Like I said, depend on the future of this working group, whether we can take it somewhere or not. Right. Okay. There is a button on it. Maybe the battery is gone.
Hi, this is Marco from RISE, and an update to this robot scheduling draft now version 2. Quick recap: the document describes both an attack and the solution. The attack is possible for an external adversary, even in the presence of security and the link layer. It can be performed very efficiently in a stealthy way, low power consumption. So even if you are on battery. It's about essentially inferring with 100% precision the full schedule of a victim node, and then selectively jam with 100% accuracy and effectiveness every single transmission and reception of that node. The document proposes also a solution that doesn't require any additional communication among the network nodes. It's all about local efficient computation for shuffling cells at each slot frame in a synchronized way among the network nodes. So as a result, you have a schedule that is still collision-free and consistent for all network nodes, plus is now also unpredictable for an external adversary. So essentially, the attack is neutralized. What happened after Prague? We got reviews on the list and promised. Pascal, Tengfei, Michael, thanks very much for that. And then we got additional comments on a particular point I'll raise later from Michael and Malaysia on the list again. As a summary of updates, we mostly addressed the reviews and made a number of improvements in the document. A quick overview about this. Tengfei had 1 comment on clarifying the meaning of a symbol in an equation. Done. Michael wanted already additional motivations that we had in the introduction of why these attacks make particular sense, for instance, in order to harm a competitor's network without being detected or harm yourself. We also fixed the presentation of the actual shuffling mechanism used to produce the robust scheduling to be fully aligned with the latest Fisher-Yates version. So to shuffle n elements, you don't really need n swaps, you need n-1. So it's even a little bit more efficient and makes the related counter grows even a little slower. Thank you. Malaysia also recommended to relax a little bit a recommendation we were having in the previous version, where we were saying, well, it's just recommended to shuffle not only channel offsets, but also time offsets. since in some use cases or networks can make sense to just not do that for the sake of network performance, especially in the multi-hop context. We remove the recommendation, so we are just now describing the two possible shuffling and describing the pros and cons of not doing or doing time shuffling. Then the biggest update came actually out of a comment from Michael. They wanted to have some example outputs from essentially proof of concept implementation showing the produced alter schedules out of the original one. So I made a proof of concept implementation using the OpenSSL primitives, and you have an appendix now in the document with a full example performed by a network node for 2 slot frames in the row with full details on the configuration on that node and the network, the original schedule, and how it becomes.
Cool, thank you. I haven't read it, and I will read it tomorrow on the train. Sounds exciting.
Thank you, Michael. Maybe you meant I would like to see the example at some point in time, but I interpreted it, I would like to see it as soon as possible. Yeah. Yes, so after the reviews, the discussion continued a bit on the list, especially between Malisha and Michael, to cover the particular aspect of key renewal in the network. So right now, using the minimal security framework, in the join response, we are additionally providing also the permutation keys needed to implement this solution. And in case you have network rekeying, essentially, well, you are supposed to use the same message again and distribute new permutation keys as well. Of course, different nodes will get the new key sets at different times. So for a while, you might have misaligned permutation keys, and different schedules will be produced for a while, and this needs to be minimized at least as an impact. So the big question is, when are you supposed to switch to the new permutation keys? And the best answer is apparently, well, not exactly when you switch to the new network keys. That was followed by a pretty complicated discussion on the list that I'm trying to summarize here in this slide that looked like a promising way forward. We need yet a further parameter in the join response as a permutation index that is essentially incremented at every rekeying. It indicates the epoch of your permutation key, so univocally, your permutation key set. Then how the switch can happen based on that? Well, the exact permutation key you want to switch to can be included in the enhanced beacons as a newly allocated information element value. Such enhanced beacons protected with the new network key set will be sent in the network by the trusted border router. And the network knows that at some point will start eventually to be able to process and validate that enhanced beacon will for sure have, of course, network keys, but also the new permutation keys. And at that moment, they will switch to them and will start producing the new schedule. Summary, we addressed the reviews, and we have a big open point with a promising direction, especially to when to switch to the new permutation keys in the presence of network rekeying. So all considering the status of the document, the outcomes from the reviews, we believe this is in shape for working group adoption consideration.
So I guess this is a question for the chairs. Okay, so the one thing is that it really depends if the work group continues or does not continue, because adopting something in a work group which will stop, doesn't make much sense. Another question is like for Tero, because you're the only 802.15.4 hat in this room, is like what I've seen apart, we exchange the keys like we do for the other layer 2 keys, so it's our job, but once we get there, all that I see described here seems to be a back layer operation. We don't actually control where the cells are. You do. So I feel personally at off that it's very interesting work, but I also feel that it belongs to you, not to us.
Yeah, I think it's going to be more like it should be done in the Mac. It should be actually, part of the work, because one of the problems is that the upper layer doesn't know anything about link. It doesn't know anything. Upper layer doesn't know which link was used to send the frame out. It doesn't know what time slot or ASN or what channel is sent the frame out. It's just configuration with the Mac. Mac will then run stuff in a way. Yes, you could actually change the the channel hopping sequence every now and then, which would actually give you certain this kind of features. But do that. But of course the problem is that upper layer can't coordinate that. They can say, oh, I do it now, and Mac will do it 10 ASNs later, because that's when it happens to have that. Everything that is done by the upper layer happens at some point of time in the future in the Mac, and there's no way of to coordinate or force the upper layer to do, or the Mac to do something. I don't think it actually would be very. Yes, in some implementations, you probably, if you do everything in software, yeah, you can do it, but it wouldn't be part of the standard 15.4. Or let's put that, if you do 15.4 TSCH implementation, it might not be able to allow you to do that. It might be saying, oh, I'm just implementing things that are required by IEEE, and they don't require you to have this kind of features that would allow you to mess up scheduling it that way.
So how could we progress? If we wanted to have this happening, should we propose it to IEEE, present it as a...
Yeah, I think actually, yeah, it probably would be a new mode to TSCH, something like. There is a couple of things that are happening in the different files that are doing a little bit similar things, and the question is that how much you actually, how much is going to be really used, because that's actually one of the things that, because you need to have to be able to have in IEEE we have a PAR, you have to have a PAR which tells you what the project you're going to be doing, and then you need to have this kind of criteria saying that you need to have a wide market use for it. It isn't enough to be, oh, in academia we think it would be nice to have this kind of feature. That's not enough for them. They don't want to start standardizing thing if it's only for some very limited use. They want to have lots of people. They would need to have some real hardware vendors implementing or saying that they are going to be implementing this. Otherwise, they are not. And actually, more than just one would be.
So let's continue on the mailing list to see if there is a way to progress this with the IEEE and how that could happen.
I think it actually Pat Kinney would probably be the best person to ask, because he knows both TSCH and he knows the IEEE.
And he's our contact for 6TISCH, is our liaison or something, right? So to do for the chairs, I mean, start a discussion with Pat Kinney and yourself, and see, because I mean, without support from IEEE, this is a dead end, right? It has to happen there because they have the control of what you're suggesting. We don't.
Okay, thank you.
Okay, and with this, we are closing this meeting. So thank you all. It's probably not the last 6TISCH meeting. We hope we meet in Bangkok. After that, all bets are off. So we'll discuss with Suraj if we reach out for scheduling the time slots for the deterministic 6TISCH, or if we just close this group. And with Thomas, obviously, who could not be with us today. Thank you all. Dismissed. Blue sheets. Everybody signed the blue sheets? Yes. Okay, I'm sorry, but that's not. What? Blue sheets. You have to sign, one here. So that's what you don't require to change the this can even pursue all IEEE together. Well, we don't have much to say, right? Yes, we need to check something, right, to carry the but this is easy. That's hard to get IEEE to can you take them? Sure. Because that's your chair. So to the registration of the IETF, it's